Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Hello dear students and welcome to CET JEE classes of relations and functions, and now we are discussing the concept of functions, and we have already discussed in the previous class the meaning of one and many one function, and in today's class, in this particular class, we will discuss the concept of onto and into function. Well, when do you say the function is onto? A function f from a to b is said to be onto if every element of b is the image of some element of a. I'll explain this with an example. Imagine you take f of x is equal to 2x and the function is from n to n, natural numbers to natural numbers. Then what you have here is natural numbers, and you got natural numbers here too. Okay, it goes on like that. Okay, all the counting numbers, and the function is f, and how it is defined, f of x is equal to 2x. Therefore, what is f of 1? F of 1 is 2 into 1, obviously it is 2. And what about f of 2? F of 2 is 4, and so on. You can understand that. So 1 is related to 2, right? And what about 2? 2 is related to 4, 3 to 6, 4 to 8, 5 to 10, and it goes on like that. Well, now understand that 2 is the image of 1, 4 is the image of 2, 6 is the image of 3 because 3 is mapped to 6. Okay, so 6 is the image of the element 3. Understand the terms. These are the images and these are the elements. Okay, so if every element of b is the image of some element of a, so every element 1 should be the image of some element of a. So this is a, now that is b. Well, and 3 should be the image of some element of a. Yeah, 5 should be image of some element of a. Now is it the case here? No. Okay, this does not happen. Now this does not happen because you have these numbers, odd numbers, which are not the image of any element of a, right? So in other words, for every element y belongs to b, that means I'll take 5 belongs to b, b is n itself, there does not exist any x in a. All right, this is b and that's a, such that f of x is equal to 5. So can you find any x in a? Can you find any x in a so that f of x is equal to 5? No, you don't get any x there. You don't get any element in this place. You don't get any element. So therefore this is not onto. So I hope this concept of onto is clear enough. That is this statement. All right, now let me explain this. What is the meaning of range is equal to codomain? If this happens, then it is onto. If that does not happen, then it is into function. Not onto, is into function. All right, so this function is into. Now let me explain that last statement which says range is equal to codomain. So why do you think that both are equal? Understand what is the range here. See, range is only those elements which are related. In other words, if I write this function in terms of ordered pairs, then I must write 1 comma 2 and 2 comma 4, 3 comma 6, 4 comma 8, 5 comma 10 and so on. Infinite function, alright, because the sets are infinite. Well, so now first elements are the domain values. So domain is 1 2 3 4 5 6 7 8 natural numbers, set of all natural numbers is the domain of this function, whereas range is the second elements of the ordered pair in the relation or the function, right? So 2 and then you got 4 and you got 6 8 10 and so on. All the even natural numbers are the range values here. What about the output values? So these are the output values, correct? Okay, that means 2x values. So whatever x you put, you get double of it. If you put 1, you get 2. If you put 2, you get 4. So that's the output. So it makes double. Okay, well, now what is the codomain? See, codomain is the whole second set B. The full second set B is called the codomain. That means n is the codomain, natural numbers. It includes 1, 2, 3, 4, 5, 6, all the natural numbers. Now, do you think they are equal? They are not equal because you don't have 1 here, you don't have 3 there, you don't have 5. Therefore, they are not equal. So, range is not equal to codomain in this case. So, what do you say? F is not onto, or you can say F is into. So F is into. Well, so that explains these three things with an example. I hope you understood. Let's move on to the next thing, that is solving a few examples related to these concepts.
Don't forget to like our video and subscribe our YouTube channel for all the updates.